Today we are going to discuss on a Deadman inactivity and bird nest formation. So before discussing the solution, let us first understand the problem. In a blast furnace operating with a high pulverized coal injection or PCI, not all injected coal burns completely inside the raceway. This becomes a challenge for blast furnace operators or the technologists that combustion never complete to 100%. As shown in the left figure, you can see some unburned coal, coke fines, and char accumulate at the raceway boundary. Over time, these material form compact cell-like regions known as bird nest. The bird next act as a barrier between the raceway and the deadman. The concept is to be very clear to the operators that raceway and deadman is being barricaded by these bird nests, which are basically segregation of the very fine particles, fragmented particles of the coke pieces. So because of this barrier, the flow of gas and liquid through the deadman becomes restricted. The graph on the right shows the relation between PCI rate and deadman permeability. As you can see that the way we go on increasing the PCI rate, and as you can see that continuous rise leads to deadman permeability down, and this is quite obvious, especially when we go beyond 150, 200 and 200 plus mark, that drastically drop. The consequences are significant, and gas flow shift from furnace center towards the wall region. Now, once a lot of gases take turn around, um, change in its passage from center to periphery. Uh, so there is a lot of heat loss imbalancing of the furnaces, which leads to ultimate the wastage of energy, and that energy is to be compensated in to keep the regime or the chemistry of the blast furnace steady. So the cohesive zone becomes pretty also change due to all these, and becomes more W shape. The deadman temperature decreases and liquid drainage becomes challenge. Ultimately, for stability, productivity, and campaign life are negatively affected. Therefore, maintaining an active, permeable deadman becomes a critical challenge, especially under high PCI operation. So, the graph which is on our right hand side is the final outcome of this slide, where it shows that with the increase of PCI rate, our deadman permeability also goes down, and which also result in affecting the campaign life of the furnace, which is very important. Coming to our next slide, which is on the innovation, we are talking all about to activate the dead man, that is oxygen capsule concept and mechanism. So to address this problem, an oxygen capsule was developed. The capsule is approximately 200 millimeter long and 20 millimeter in dia, as it's shown very clearly in the slide. So inside the capsule, about 30 cubic centimeter of liquid oxygen is stored within a robust metal casting. The concept is simple but powerful. First, the capsule is pneumatically injected through the PCI lances into the raceway. Because of its momentum, it penetrates through the raceway and reaches the bird nest region. Once exposed to the extremely high temperature environment, the capsule bursts. The liquid oxygen rapidly vaporizes and expands nearly 8 times in volume. 8 times in volume. This oxygen immediately react with the surrounding unburned carbon, coke fines and char. The combustion generate intense localized heat, which is quite obvious. As a result, the accumulated fines are consumed or swept away, the burned structure break down and permeability is restored. In short, the oxygen capsule directly attack the root cause of Deadman inactivity rather than merely treating its symptom. So, now as you can see, uh, that after developing the concept what we have discussed in slide number 2, that is the earlier slide, field trials were conducted at our furnaces, other furnaces worldwide, and these in particularly BF number 3 of Gwangyang, that is in South Korea. BF3 they tried, and this furnace has a inner volume of around 4,600 cubic meter and a hard dia of 14 meter plus, that is 14.3 to the very specific. The left chart, as you can see, it presents the result of single 2-year test, that is following uh, oxygen capsule injection into the 2-year number 5, particularly 2-year number 5. The hot blast flow rate increased by approximately 10 to 15 normal cubic meter per minute. So at the same time, the neighboring reference 2-year showed almost no change. This clearly indicate that two things, that is the local permeability in front of injected 2-year improve. There is no doubt about it, and the right chart, uh, that is that is what we said, that completely there is a increase in permeability that has been proved as for the our left graph is concerned. The right chart shows the result of multiple 2-year injection. Before the test, several 2-years had significantly lower flow rate compared with the other, indicating poor permeability. After injection, the flow rate increased substantially and become more uniform around the furnace circumference. This demonstrates that the method not only improves local permeability but also restores circumferential balance. And this field result provides strong validation of the oxygen capsule concept, and which is the data are depicted in the slide very well. Now, finally, this slide summarizes the complete activation process. The process begins with the injection. The oxygen capsule is loaded into the shooting system and injected using compressed air at approximately 120 bar pressure. Next comes penetration. The capsule travels through the raceway and deep into the Deadman region. In the reaction stage, the capsule bursts under high temperature condition. Liquid oxygen rapidly convert into gas and react with the unburned carbon and coke fines as it is shown. This combustion generates heat and removes the compact burned layer. And once the burned layer gets ease, we have already seen the data shows, which is pretty very near to the improvements, and improvement is visible. The final stage is activation. Gas and liquid permeability are restored, Deadman temperature increases, flow path reopen, and furnace operation becomes more stable. To conclude, the oxygen capsule is a novel, direct and effective Deadman activation technology. It removes burned formation by combusting the accumulated carbonaceous material. Filters confirm the improved gas permeability and better circumferential flow distribution. Therefore, this method offers a practical solution for maintaining blast furnace stability and productivity, particularly in modern high PCI operation. And we can see that these all things what we have discussed is being well proven.